Okay, guys. This is your homework. It's on at Moto. You can print your own copy or do it on a separate sheet of paper. It's important that you at least know the property or what you need to do for each problem. It's a mixed practice, so it's covering everything we have done with circles so far. I'm just going to go over a couple that are similar to other problems. You do need to complete the whole set. It has chords, tangents, and secants. Also some radius. You're dealing with angles and also arcs. So it's like I said, it's a mixed practice. Now, on the first one, I'm hoping you see that you have two chords here that are intersecting. So we're doing chord rule, which is part times part. So 18 times x is 18x. That part goes together. Part times part. The products of the part are going to be congruent. So 18 times x to 18x. That part is going to be equal to the 15 times the 12, which is really 18x equals 180, and you're solving for x. So 1 is like 2. 3, I'm hoping you see that you have secant, or some of y'all remember ow. So outside times the whole, if I do the first secant that I have here, outside is x times the whole, which is x plus 4, is equal to, for the second secant, outside would be the 5 times the whole secant, which would be 12. And so you are going to have a quadratic here when you multiply. So we have x squared plus 4x, sorry about that, equals 60. We want the quadratic equal to 0, so x squared plus 4x minus 60 equals 0. And then we're going to factor to solve, which I know you know how to do. So, but you are going to have some times where you're going to have to factor to come up with the solution for x. Another example of that, when you have to factor, would be on 4. So just in case you weren't too sure about the factors, let me make sure. X plus 10 and x minus 6. And so our solutions are x equals negative 10 or positive 6. Okay. Now, 5, we have what we call tan secant. Tan secant requires you to do the tangent square equal to L. Okay, so the tangent was the TR. Over here is your tangent. So that's x squared is equal to the outside, which is 8, times the whole, which is 18. So basically x squared equals 144, and then you're going to take the square root. So x equals plus or minus 12. Okay, so you have tan secant on number 6 as well. Now number 7, which is going to be similar to number 8. Yeah, number 18. You're going to have to label the parts, and we're going to, this is kind of like our pulley system, our chain system that was on our notes, where we're going to have to draw a parallel segment to create the rectangles. But let's just get the parts labeled for us. So we have XZ is 3, WV is 9. Those are both radius, one in the large and one in the small circle. Then UT, the distance between the circles, is 10. And they want us to find WX. Okay. Now, in order to do that, this is what I was saying, you're going to have to draw a perpendicular segment that's parallel to VZ. So it's going to, and we want it to go, so it's going to create a little right triangle above it. So if this is 3, okay, and if I have a rectangle here, and I know it's not drawn to scale, so let me fix this for y'all. There we go. All right, so if this is 3, then we would have 3, and the remaining part, since the radius is 9, would be 6. And if UT is 10, but I know that the radius, is 9, and this radius is 3, then I could figure out the total distance here, and that would be 22. So that means it's 22 opposite, because they're parallel, and we got like a little parallelogram there. So you can find x using Pythagorean theorem, which you have is 6 squared, plus 22 squared is going to equal to x squared. So Number 7 here is like number 18. You're going to have to do the same type of thing. It is not a perfect square. You can give me a decimal answer or simplify the radical. Now, when you get here using everything you know, especially whenever you have a radius or a diameter perpendicular to a chord, what happens to that? This first thing we need to recognize is the chord AC is going to get bisected. So will the arcs. Okay, and we can swing the radius, meaning we can draw another radius here, like from O to C, and that is also 16. And then this is B to O is also a radius. So if that's 16, if the whole radius is 16, the remaining part here from F to O is 11. So now we're starting to see some right triangles, some Pythagorean theorems. Now, the only thing is to kind of remind you, when you get to number 11, because they want the distance of OG, OG is that distance right there. We are not looking at a radius. The radius is the hypotenuse. So to find that, because since we don't have the length of ED, you're going to have to use trig to find OG. We know that if we were to draw the radius, because it's perpendicular, that chord would get bisected. And also, if I were to draw the radius on this side, the central angle would be 80, so that makes that angle in the triangle 40. It's not a special right, but you could do cosine of 40 equals the adjacent, which is x over 16. So you are going to use some trig in some of these problems to help you find the missing segment. 14, my only clue or help, hopefully, is that they tell you that the two chords PS are congruent, so that means they're equal distance. We just kind of talked about 15 and 16 in the previous picture. When I see that box, the chords get bisected along with the corresponding angles. So this arcs. So the same thing is happening to the large major arc as well. I'm really not going to stress or I'm hoping you can do 15, 16, and 18, 17, excuse me, because we've done plenty of those in class. Along 18 is like number 7. We've had this 19 on some homework checks already. It was on a previous homework assignment. The thing you need to remember is that the tangent is always perpendicular to the radius. So they don't tell you, but you are to know that there's a right triangle there. And your hypotenuse here is x plus 2. So a squared plus b squared equals c squared would be x squared plus 8 squared equals x plus 2 squared. We did this part of our guided practice and with our notes with our very first pink paper. So x squared plus 64 equals, and we talked about the shortcut when you square a binomial, x squared plus 4x plus 4. And the x squares are going to end up canceling out, so there's no really excuse for us to not solve that. Again, remember your tangent is perpendicular to the radius, and the radius is perpendicular to a chord that bisects it. When you get to 21 and 22, now we're talking about inscribed angles, or using the theorem for inscribed angles. N is that vertex is on the circle. So if they're pointing to angle MN, or the angle N is 80, the intercepted arc is from M to Q. Okay, the inscribed angle is always 1/2 the intercepted arc. So you should be able to use that relationship to find the missing arc and the missing angle. But when you get to 22, you were needed to watch the completion of your notes. It was posted on Emoto as well, where it talks about the interior angle and the exterior angle, the last 2 boxes on your green sheet. Here we have an exterior angle. Okay, angle A is outside the circle. Whenever it's outside the circle, the exterior angle is equal to 1/2 the difference of the intercepted arcs. So your intercepted arcs that you have that you're going to use, we have FD right there, and you have BC, which you're going to have to calculate, which you can do because you have the other arcs, and you know that the sum of, or the distance around a circle is 360. So that's your exterior angle. But then when you get to 25, and we're missing a picture on 27, it looks like. Okay, well, we're going to skip that. Oh, sorry, 25. Now we have an interior angle, okay? But I would use the angle, the linear pair, to help you find angle 2 because I have the intercepted arcs for its linear pair. But any interior angle is now half the sum of the intercepted arcs. So that was on the notes as well. Okay, so 26, the combination. Obviously, we see now we're going to omit 27 because the picture is missing. And then 28, you have a combination using all your properties, all which your relationships for whether it's a central angle, inscribed angle, interior angle, whether it's an exterior angle, whether it's a tangent to a radius, using all your relationships to fill in the missing angles or arc lengths. So one thing I would, I guess, suggest to you is label always your given. So they have your arc 76, which was AB, and then they tell you the arc DC is 110, and then they tell you that you have DB as the diameter. So DB is cutting the circle into a semicircle to 180 half. So now that I know that, I can find the remaining arc CB to be 70. So I would have a semicircle of 180. And then the remaining arc DA over here, from here to here, would be 104. Okay. And so now we have all our arcs, and then it tells you we do have a couple of tangents. It says ED and EA are tangents. So A, that's your point of tangency. I could say, or you should see that OA is a radius, so you should know a relationship there. I'm not going to write it. I talked about it just a while ago. All right, so good luck on this homework. Be ready for your quiz. Post questions, come to tutorials, and have a good day.